Hello, ladies and gentlemen. Today we are going to take a look at something called the converse of our parallel line statements. So today we're going to be answering the question not, what is x or what are the angles equal, but instead we're going to ask ourselves, are these lines in fact parallel? And how do we know? So our learning target today is that we can use information in a diagram to determine if lines are parallel. And now that's more than just saying, yep, they're parallel because I see the little extra arrows marked here on the picture. It's a little bit more than that, okay? So let's consider where we've been. We were just talking about this whole idea of a theorem or a statement about these parallel lines and their corresponding angles and alternate interior angles and things like that. We had statements like, if two lines are parallel, then alternate interior angles are congruent, or corresponding angles are congruent, or consecutive same side interior are supplementary. This is the way our statements were written, where we had, if we know we have two parallel lines, then something happens. Then these angles will be equal, or these angles will have equal measure. So with that idea, this is where we've been. Now what we do today is a little bit different. We will be asking, are the lines parallel? So we're going to be looking at something called a converse. Now a converse just simply means you switch around the two parts of that statement. So instead of saying if the lines are parallel, now we say if alternate interior angles are congruent, then we know the two lines are parallel. So we're going to be using this idea of a converse where we're looking for something different this time to answer whether or not lines are parallel. So you already have all of these in our little foldable. We wrote these four theorems in there. We have these four theorems. If two lines are parallel, then corresponding angles are congruent. And now we're going to reverse each and every one of them to say if we have corresponding angles congruent, then the lines are parallel. So these are the converse statements that you need to get into your notes. So if corresponding angles are congruent, then we will have parallel lines. If I see alternate interior angles are congruent, then we know the lines are parallel. If we see alternate exterior angles are congruent, then we know the lines are parallel. And if we have same side or consecutive, is what we called them, interior angles are supplementary, then we know the lines are parallel. So these are the converse statements that go with the four theorems we have in our foldable. Again, the same ideas, but we're flipping the beginning part of the statement around with the last part because now we're asking, are the lines parallel, and what clues will I see in order to make that determination? So make sure you take a little time. I would pause the video and get all of these written down in there, and then we're going to look at a few examples. So here's the first example. Oops, too much animation there. The question was, are these lines parallel? And we need to be able to explain our answer now, okay? So instead of just saying yes or no, we need to put an explanation into what it is that we're seeing. So this picture right here shows that we have two lines marked with those little slashes telling us that they are in fact congruent. And when the two lines are congruent like that, that is something that we want to look for as an indication that the angles may be showing that the lines are parallel. So if I look at these two angles that are marked congruent, it appears that these two angles we would label as alternate interior angles. And because these alternate interior angles are marked congruent, we can then say that the lines, yes, are in fact parallel to each other. So we would say M is parallel to N. Now instead of writing that out in words, you can do M, the little symbol for parallel is pretty much a skinny 11, right? Our two little mini parallel segments there. And N. M parallel to N. And the reason we know that here, I'll animate that in here, the reason we know that is because those alternate interior angles are congruent. Okay, so that's how we would answer these questions. Let's look at a second one over here. So different angles are marked congruent here. Is this enough for us to know that the lines are in fact parallel? Well, if I look at those two angles, this one and this one, I would say that they are alternate exterior angles. They're in between, or they're exterior on the two parallel lines. And so we would say again, yes, that M is parallel to N. Why? Because we know that we see alternate exterior angles are congruent. So if you want to at any point write a couple of these examples in there, but you do not need to write all of them, or if you just want to sit back and watch them, that would be fine as well. Okay, now let's look at this one. Are these lines parallel? So be thinking, is that a special relationship that determines if lines are parallel? Those two angles are in fact corresponding angles. So again, we would say M is parallel to N. Why? Because we see that corresponding angles are congruent. And now this one. What about these two angles? These two angles are marked congruent, and they would be equal, they would be congruent, but these two angles are vertical angles. And if you look through your converse statements, there's nothing in there about vertical angles making any sort of parallel line judgment based on that. In fact, vertical angles are always congruent, whether the lines are parallel, perpendicular, anything. Vertical angles will always be congruent. So I would say that M is not parallel to N, or we don't know for certain, because there's not enough information in this picture. All we know is that vertical angles are congruent. So we cannot make the determination that those lines are in fact parallel. What about these two lines, A and B? Are these lines parallel? Well, instead of having congruent marks here, we're given some numbers. Now, these two angles are in the same side interior or consecutive interior angles. And in order to be parallel, it says if if consecutive interior angles are supplementary, so if they add up to make 180, then the lines are in fact parallel. So we would say yes, that A is parallel to B because we're seeing that 143 plus 47, yep, that is supplementary. Okay, they do add up to make 180. What about this picture over here? Well, this one has a little extra tail in here, but let's think about this angle is 114. What about this angle right here? Those two together make up that exterior angle. So this is also 114. And again, we're using numbers this time, but we can say A is parallel to B, and then we have to always justify why it is we said that. We're saying that because alternate exterior angles are congruent. What about this one? This one has a strange little triangle on the inside, but it's interior angles. This one and this one right here, those would be consecutive interior angles. So we'd add these two together, and that would be 120 degrees. So consecutive interior angles, yes, they are supplementary as they are supposed to be. So you could say yes because same side interior angles are supplementary. You could also say consecutive. That's the same word as that. Okay. What about the next one over here? The next one, let me see if I can get it animated. There we go. We have another one of those tail pictures here. This angle right here is 106. If we were to look at this angle right here, ooh, this one doesn't look right, does it? This one looks like that's 103. So are they congruent? No, right? And because those alternate exterior angles are not congruent, we would say that A is not parallel to B. So if this is A is parallel to B, this would be not parallel to B. Okay, A is not parallel to B because alternate exterior angles, this should say, exterior, let's fix that, are not congruent to each other. Okay, so that's the sort of thing we'll be looking at when we do our assignments. We'll be looking to see are the lines in fact parallel by looking for one of those clues, and then always writing our symbolic notation for parallel and justifying our reasoning as to why we believe they are parallel. Okay, so this sort of builds us to the idea eventually, guys, we are going to get to proofs, and we're building that idea of always justifying what it is that we're seeing and what we're saying in these diagrams. Okay, so I want to thank you for taking good notes today, and I will see ya.